Hello and welcome to the first video lesson for GCSE Physics. The aim of these videos is to provide you with support where you have either missed a lesson in class or you want to review work you've gone over to help you revise for an end of topic test, mock exam or for your real GCSEs. To get the most out of these lessons, you should always have a pen, paper and a calculator to hand. You should make notes on the key information that is shared with you throughout the lesson, pausing the video where necessary to copy down diagrams and any key definitions needed. You should attempt each question and task that is presented to you, pausing the video whilst you do so. Then you should mark your work and note down any ways in which you can improve it. For example, did you use a key word? Did you show all your working out for calculation questions? Did you miss out any of the important points that were part of the answer, etc, etc. So let's dive straight into it. We're going to be starting today by looking at the structure of an atom. So the first task I would like to have a go at is think what is the smallest thing that you can think of and roughly how big is it? Pause the video, come up with a couple of ideas and then press play. So there might be a range of different answers here. I've given a picture of an ant on the board just to give you a kind of idea to be thinking about small things. But what I'm hoping is that at least some of you watching this video will have thought, well, atoms are very, very small, and you might have put an atom down as an example. For roughly how big an atom is, well, we're going to look at exactly how big atoms are later on, but obviously we know that they are too small for us to be able to see. They are in fact actually 1 × 10 to the power of -10 meters in diameter, which in other words is incredibly small. There are smaller things than atoms though. Some of you might have delved into the substructure of an atom and suggested protons or neutrons or electrons, which will be great answers as well. So that was just a nice starting activity. So let's look at what the structure of an atom is like then. On the board is the model that we currently use to describe the structure of an atom, and there are a few key features to this. First of all, you will see that the electrons surround the centre of the atom, which we call the nucleus, and each of those electrons is in either a shell or an energy level. Those two words can be used interchangeably. So those dotted circles that the electrons are sat on, we call shells or energy levels. Then in the centre of the atom we have the nucleus. The nucleus contains 2 types of particles, protons and neutrons. Now let's look at the structure of each of those particles. So we have protons, neutrons and electrons. Now the actual mass of each of these particles is very, very small. They are very, very lightweight into literally 0.000 loads of zeros kilograms. So we don't want to remember the exact mass of them because it's not very helpful to us. Instead what we use is the relative mass. The word relative means compared to. Now we're going to be comparing the proton and the electron. We're going to be comparing the neutron and the electron to the proton. So we're just going to say that a proton has a relative mass of 1. Now the neutron weighs exactly the same as a proton. So because it has the same weight, the same mass, we can say that the relative mass of a neutron is also 1. Now electrons are much more lightweight than the protons and the neutrons, so their relative mass is less than 1. To be specific, it is 1/2000 as a fraction or 0.0005 as a decimal. Either of those will be fine to give us the relative mass of an electron. Then we can consider the charge. Charge, of course, can either be positive, negative or uncharged. Protons are positively charged. You can remember P for proton and P for positive. So we say that they have a relative charge of +1. The difference between a proton and a neutron is that a neutron has got no charge, so we say that the relative charge of a neutron is 0. And then finally, the electron. The size of the charge of an electron is the same as a proton, but it has the opposite charge. So we say that the charge of the electron is -1 because it is negative. Now let's consider the size of the atom, how far away these particles are. Well, most of an atom is actually made up of empty space. Now, to help you put that into some sort of imagination, so you can visualise it, imagine that an atom is the size of Wembley Stadium. So we're looking at it really zoomed in. It's made up of the following parts. The nucleus would be roughly the size of a football on the centre spot if the whole stadium was the atom. The nucleus contains smaller parts about the size of cricket balls called neutrons and protons. The electrons would then be two peas basically flying around the whole stadium, around the outside edges of the seats. The rest of it will just be empty space. So how big is an atom then? I told you I'd give you the exact number, and here it is. Atoms have a typical radius of 0.00000000001 metres. Now I would never expect you to remember that number because it is very, very difficult to, and you'll probably write it down wrong if you try to remember it. So instead, scientists have come up with a better way of remembering very small numbers like this, and we call this method of remembering numbers standard form. So instead of quoting it as this decimal, we can quote the size of an atom, the radius of an atom, instead as being 1 times 10 to the power of minus 10 metres. Now that number you do need to remember. The radius of the atom, of course, is the distance from the centre of the nucleus to the edge of it. Now, when we look at this, we need to know, well, how have we got from that decimal number to that number in standard form? And there's a couple of things to think of. First of all, where did this minus 10 business comes from? Well, there's a couple of ways you can think about it. You can start off by noting that in fact there are 10 zeros before the 1, including the 1 in front of the decimal point, and that's possibly the easiest way. Instead, in maths though, you might have been taught to count how far you would move the decimal point when moving it to get it to be behind the 1. So for example, if the decimal point was here where I put the laser cursor, that would move once, twice, 3, 4, 5, 6, 7, 8, 9, 10 times to put the decimal point behind the 1. Hence, that is why we've got times 10 to the minus 10. And then, of course, you might wonder where this, why it's a minus sign. It's because that is the way that we are moving the decimal point as well. I can now get rid of the laser pointer. Okay, so you do need to remember that the radius of the atom, the typical radius of an atom, is 1 times 10 to the minus 10 metres. You do get some that are bigger. Obviously, the further down the periodic table you go and they have more and more electrons, the radius of the atoms do increase, but generally speaking, the radius of an atom is 1 times 10 to the minus 10 metres. But what about the nucleus then? The nucleus is obviously where the protons and neutrons are, in the centre of it. Well, the nucleus of an atom has a radius of 0.0000000000001 metres. Again, you're not going to be able to remember that or write that down just by listening to me reading out a list of zeros. So we can put that into standard form because it is easier to work with. And so the nucleus has a radius of 1 times 10 to the minus 14, following the exact same logic that we used earlier on for the radius of the actual atom itself. This decimal point would have to move 14 places to end up being behind the 1 that we've got there. There it goes. Alternatively, of course, you can think to yourself, well, there are 14 zeros in total in front of that 1. And there is the explanation of it again for you to look at. So let's have a go at some tasks then. First one is a maths challenge. You will need a calculator to be able to do it. It says write down typical values for the radius of an atom and the radius of a nucleus, and then work out what fraction is the radius of a nucleus compared to the radius of an atom. Pause the video, have a go at this question please, and then press play to mark your work. So the first thing was to write down typical value for the radius of an atom. The radius of an atom, of course, is 1 times 10 to the minus 10 metres. You were then asked to write down the radius of a nucleus, which will be 1 times 10 to the minus 14 metres. And it then says what fraction is the radius of the nucleus compared to the radius of the atom. To work out a fraction, we put one number on top of another one, so we put the radius of the nucleus on top of the radius of the atom, doing 1 times 10 to the minus 14 divided by 1 times 10 to the minus 10, which the calculator simplifies for us to 1 over 10,000. Maths challenge 2. How many times larger is the radius of a magnesium atom compared to the radius of a magnesium nucleus? The radius of the magnesium nucleus is 1.5 times 10 to the minus 14 metres, and the radius of the magnesium atom is 3 times 10 to the minus 10 metres. Please pause the video, have a go at the question, and then press play to mark your work. So, to work out how many times greater the radius of the atom is, you would actually do the radius of the atom divided by the radius of the nucleus to find out what you would need to times the nucleus by to get to the value of the atom. So into your calculator you will put 3 times 10 to the minus 10 divided by 1.5 times 10 to the minus 14, which will give you an answer of 5,000. So we can say that in this instance, the radius of the atom is 5,000 times larger than the radius of the magnesium nucleus. Okay, the last thing I would like you to do in this lesson is to have a go at this exam question. It says, describe the model that is now used for the structure of an atom. In your answer, you should give details of the individual particles that make up an atom, include the relative masses and relative charges of these particles, but do not include a diagram in your answer. What I would like to point out before you start is that this question is worth 6 marks, so you will need to do quite a bit of writing to be able to answer it, and please make sure you include a minimum of 6 points. Pause the video and then press play once you're satisfied that you've given this question your best go, and then you can mark your work. So let's go over the answers then. Now, your first mark for this will be for any mention of protons, neutrons and electrons. If you've mentioned all 3 of those subatomic particles, you get 1 mark. Now, the question did tell us to give details about those particles, including their masses and charges. So we can say that a proton has a relative mass of 1 and a relative charge of +1. That gets us a 2nd mark. A 3rd mark is available for saying that neutrons have a relative mass of 1 but a relative charge of 0. And then we can get a 4th mark for saying that electrons have a relative mass of 0.0005 and a relative charge of -1. But that is only 4 marking points that we've got down so far. We therefore need to give more information about the model that's used for the structure of an atom, so we need to describe more about it. You could say, for your 5th mark, that the protons and neutrons are found in the nucleus of an atom, and therefore for your 6th mark, you could say, therefore, electrons orbit the nucleus at specific distances from the nucleus in energy levels or shells. You can also have credit for saying that most of the atom is made up of empty space if you haven't already got 6 marks. And finally, it would also be possible to get a mark for saying that in an atom there are always the same number of protons and electrons.